Hi guys, welcome to NunleyMathShorts, where we take our longer video lessons and condense them down to just their most important points so that students will have those handy for quick review. You'll notice today we're talking about slope and the point slope formula, so let's go ahead and dive right in. Now, if this was a full Nunley Math video, we would spend some time reviewing what the slope of a line is, because it is the ratio between the rise and the run of that given line. So for example, if I have this blue line here, you can see that we rise 3 spaces at the same time we're running 5, and that gets repeated throughout the entire course of the line. But we would also spend some time talking about the fact that that rise can be calculated by subtracting the y portion of the coordinate. Notice we ended at 4 and started at 1. 4 minus 1 is 3. And we can do the same thing with the x portion of our coordinate, 7 and 2, to find the run of 5. And in fact, if we look at those as generic points, x1, y1, x2, y2, we can develop the slope formula. Now, in a previous lesson, we will have taken that slope formula. We will have talked about the different results you could get. When you calculate it, you could get a positive slope moving up from left to right, a negative slope moving down from left to right, a slope of 0 as we move horizontally, and a vertical line gives us a slope that's undefined because you cannot divide by 0. We also would spend some time talking about how we can calculate the slope if we are given 2 coordinates, even if we don't take the time to draw the line. So, what we want to do in this lesson is we want to take that slope formula and we want to rearrange it just a little bit. Now, ordinarily, I would go into great detail about that, but because this is a short, I'm just going to talk about the fact that we can use the property of equality to multiply both sides by whatever the denominator is here on the left, and then use our fraction rules to simplify the right side to be 1s. If I simplify it, it looks like this. I can then use my commutative property that says multiplication can change orders without changing the results to move my m. And then the symmetric property allows me to change what side of the equal sign things are on. If 2 things are equal, it doesn't matter if they're on the left or they're on the right, it's the same thing. And then I would just change my y2 and x2 into unknown values x and y, and that would create the point slope formula. As always, take care of yourselves. Hope to meet you back here soon. Thanks. Bye-bye. Notice what this says. It says use the point slope equation to find the equation of a line with a slope of 3 that passes through the point 5, 2. Well, with my point slope formula, that's actually very easy because this 3 right here is my slope. I'm told that. And slope is indicated by the letter m. I'm given one example of a coordinate. So this is my one example of an x, that's a 5. And the 2 is my one example of a y. Once I know those things, I'm just going to plug those numbers into this equation. Notice y1 is 2, my slope is 3, and my x1 is a 5. This is the equation of that line. Now it's a little messy, so I'm going to use my distributive property and pass that 3 out to both the x and the minus 5. And then I'm going to use my property of equality to add 2 to both sides, giving me y equals 3x minus 13. Notice this is the slope-intercept form of that same equation, y equals mx plus b. This is not a lesson on slope-intercept, so we're not going to spend much time talking about that, but if you are paying attention to our other videos, you will remember that y equals mx plus b pattern is very useful when trying to graph our equation. We would have a y-intercept or a starting point of negative 13, and we would grow by 3. We would rise 3 when we run 1. Now, if we had lots of time, I would go ahead and work these examples out with you as well. I'm going to suggest that you pause the video and try those on your own, but because we're trying to keep this very brief, I'm going to go ahead and work them out pretty quickly with very little explanation. Notice my slope and my examples of x and y are given. I substitute them in. I use the distributive property to pass out that negative 2/3, property of equality to add the 4 to both sides, and I end up with y equals negative 2/3 x plus 4 2/3. Again, pausing the video, you really ought to try this on your own. I'm going to do this one much quicker again. We're given a slope, we're given an x coordinate, we're given a y coordinate. We plug them in, distributive property, property of equality, and there's your solution. The other thing that's cool about this is if we know any 2 points that are on that line, we can still find the equation of that line using the point slope formula. Remember, when I use the point formula, the slope formula, I need a point and I need a slope. But I'm not given the slope in this example. The good news is I can actually calculate my slope the same way we've done in previous lessons by using the 2 given points. Remember, we said this formula on our first slide allows us to find the slope. y2 minus, this is a typo that I need to correct, y1 over x2 minus x1. It doesn't matter which of these is coordinate 1 and coordinate 2 as long as you're consistent. I went ahead and made negative 3y2, positive 3y1, negative 2 to be x2, positive 1 to be x1. I plug those into the formula, and I simplify and get a slope of 2. Now that I have my slope, all I need is one example of an x and a y. It does not matter which of these 2 I pick. I can pick either one. I tend to pick the one that does not have negative signs, so I'm going to use 1 and 3. At this point, it's just like the examples on the previous slide. All I have to do is rearrange it to slope-intercept form. Got the idea? Again, if we were doing a full video, I would work this out with you, but I'm going to suggest that you pause the video, try this on your own. I'm going to run through this pretty quickly for you. Find your slope, take that slope and either one of these 2 points. It does not matter which one you pick, just don't use them both. Plug those into your formula, distributive property, property of equality, and there's your solution. One last example. This one's written just a little bit weird. Don't let it throw you off. This is function notation. In function notation, what we're saying is that when x is as an 8, f of x is going to be a negative 1. In other words, this is your x and this is your y. X, y coordinate. This is your x, this is your y. We can plug those into our slope formula. I'm going to subtract my y's, negative 1 and 0. I think I picked this one as y2 minus y1. Over here's your x, x2 minus x1, and you get negative 1/2. Well, once you have your slope, you pick either of these 2 points. I tend to prefer numbers that are positive. I also like the fact that this y is a 0. That's going to save me some trouble. And from there, it works just like the others. As always, take care of yourselves. Hope to meet you back here soon. Thanks.